Hi. We want to talk a little bit about uncertainty in this video. When we make a measurement using something like a ruler or what have you, the measurement is a range, not a single number. The symbol that we use is a dot with error bars. When we write the value, we say that our measurement, say length, is equal to what we measured plus or minus some absolute uncertainty. We're saying the range of possible answers is somewhere between L minus delta L to L plus delta L. It's common as well to write the uncertainty as relative or percent uncertainty. In this case, we would write L equals L plus or minus L percent. L percent is simply delta L over L times 100. When we write our answer down, we should record to the correct number of significant digits. Our uncertainty determines how many significant digits we have in a number. The rule we'll use in the lab is that the absolute uncertainty should be given 2 non-zero digits, or possibly 1 non-zero and 1 zero digit. If the leading digit is a 1 or a 2, and only a 1 otherwise. For example, in this case, 27.5967 plus or minus 0.0176. Well, the leading digit is a 1, right? So our rule says we should go to 2. So we would round the uncertainty to 0.018. This is 3 places after the decimal, so the measurement we round to 3 places after the decimal. This number now has 5 significant figures. Second case, here's my number. My uncertainty is 0.45. Well, this is not a 1 or a 2, so we round this number to 0.5, 1 digit, and 0.5, right, is 1 place after the decimal. So this number has 3 sig figs. Now when we when we estimate uncertainty, there's 2 pieces. The instrument uncertainty, how well you can read the scale. Sometimes that's very simple. You take an object, you put it on a weigh scale, its weight is just what the number tells you, and what the machine says its accuracy is. The second thing is called the technique uncertainty, and that's how hard it is to do the measurement. Weighing something isn't hard, but lots of other measurements involve complications that we want to try to take account of. Some things to remember. Different people can have different but equally valid estimates of uncertainty. Uncertainty depends on the person. When you make your measurement, always explain why you decided on that uncertainty. The next little clip that'll be attached to this will give you a couple of examples of how we estimate the uncertainty, and in particular, how to estimate the technique uncertainty. Hi, I'm Mike Coombs, and I'm your lab instructor for this lab section. I want to talk to you about instrument uncertainty and technique uncertainty when you're wanting to make measurements. Now this is the type of ruler that we use in the lab. Most people can read this to about 1/2 millimeter. People with better eyesight could quite easily read it to 1/4 millimeter or even 1/10 millimeter. People with bad eyesight, like me, if it's too far away, probably would be safer to saying plus or minus 1 millimeter as the instrument uncertainty. So how well you can read it will determine the instrument uncertainty. There's a second part to uncertainty called the technique uncertainty. For instance, here's a little plastic spoon. All I want to do is to measure the length of it. Now let's say that I said I could read this to 1/2 a millimeter. Well, there's a couple of problems when I want to measure something like this. First of all, I have to put one end at the 0, and this end is kind of rounded. So I got to make sure that I keep it 0 on this end and take account of the rounding at this end. I'm getting something like 16.1 centimeters for this. I would probably want to go plus or minus 1 in this case because I have a little extra uncertainty. So, when we record the length of the spoon, we will give the length of the spoon, and then we would explain the uncertainty underneath. We would say we're using plus or minus 1 millimeter, even though we could read the ruler to plus or minus 1/2 a millimeter because of the difficulty in locating this end and because the front end is rounded. Hi again. I want to give you another example of how we would talk about the technique uncertainty. Here's this little spoon again. Here's my measuring device again, which probably most people will say they can read to plus or minus 1/2 a millimeter. And this time, instead of measuring the length of the spoon, I actually want to measure how far from this end the center of mass is. So how do I find the center of mass? Well, normally you do something, sort of a balance trick, something like this. Start moving it around till you can kind of get it to balance. Now, as you can guess, this is going to be a lot harder to measure. Right? I got to locate the end and then the balance point. Here the balance point, maybe 8.7, but I'm much more uncertain about this, mostly because my finger here is kind of big. So probably I might want to say it's plus or minus 2 millimeters. Remember, uncertainty is based on two things. How well you can read the measuring device. Sometimes that's easy, sometimes it's not that hard. It often depends on how good your eyesight is. The second is the technique uncertainty, how you're doing your measurement. That can complicate your measurements. Finding the center of mass is not the easiest thing to do. Thanks. So, when we record our measurement for the center of mass, under the value we say that we can read the meter stick to 1/2 a millimeter, but our technique for finding the center of mass required it to balance on a fairly large finger, so we're allowing an extra 2 millimeters for our uncertainty. Thank you.